Well, dear students, now in this video I start very important chapter of class 11, that is thermodynamics. Thermodynamics. Dynamics, what you have heard while learning about mechanics. Mechanics is the branch of physics in which we study object at rest or in motion. And the branch in which we study object in motion is called dynamics, while the branch in which we study object at rest is statics. Now the same with thermodynamics. What is this? Thermodynamics is the branch of physics that deals with the concept of heat and temperature and internal conversion of heat and other forms. I can write here thermodynamics. In general, is the branch of physics which deals heat and temperature. Heat and temperature deal with the concept of heat and temperature, and the interconversion of heat and other forms of energy. Other forms of energy. In thermodynamics, we study the internal conversion of heat in and other form of energy, and it deals with the concept of heat and temperature. So this is here thermodynamics. Now, how does it differ from mechanics? In mechanics we deal with motion or rest, and we don't have any connection with the structure and other things. In thermodynamics, actually, this is a basic concept. But when suppose a bullet is fired, so in mechanics we deal with motion, the kinetic energy and velocity, while in thermodynamics we deal with the rising temperature of the bullet, and suppose bullet strike the some wooden piece of wood, then rising temperature wood and bullet itself are considered in thermodynamics. So this is simple concept of thermodynamics. It is a branch of physics in which we study the concept of heat and temperature and internal conversion of heat and other forms of energy. Work is also a form of energy. So generally, in coming topics, we will be learning about the conversion of heat into work and work into heat. Now, there is one term, thermal equilibrium. Thermal equilibrium. Actually, a learner can state it very easily when we place a hot body in contact with a cold body, then heat flows from one to another. and after some time the conversion stop and both bodies come at same temperature, and we say that two bodies are in thermal equilibrium. This is not sufficient to say in thermodynamics here because there are other variables of any thermodynamic system. Thermodynamic system may not only be a solid piezo metal which is given heat, takes heat, may get some expansion. So in thermal system you can treat a gas and close in a container. We can deal a gas, and gas has so many variables. A single variable is not there. Not only temperature. There are four variables: pressure, volume, temperature, mass. So if we have two systems, say two independent gases, then if pressure, volume, these are two independent temperatures of given mass at given temperature. Now, if these two variables are changing, then the system is not in equilibrium. Now we can similarly suppose this is gas A and there is gas B. They are placed in insulating valve between them. This is called also adiabatic valve. Adiabatic valve. And these two gases have pressure PB, volume BB, PA, VB, and any two possible variable pressure volume of gas A and gas B may not change. If these variables do not change, then they are said to be in thermal equilibrium. So it is not sufficient to say that if two bodies are at different temperature and they are put in thermal contact, so if after some time heat flow stops and both the bodies come in thermal equilibrium, that is not sufficient to say. There are other variables. If the variables of system connect with other do not change, may be different, but do not change, then the system is said to be in equilibrium. The two systems in equilibrium. I hope, in thermodynamics, thermal equilibrium. Decides that there is no change in macroscopic variables of system. What do you mean macroscopic variables? For example, if a gas is contained in container, in a container, and its pressure, volume, and temperature do not change, then this gas is said to be in thermal equilibrium with its surrounding, with its surrounding. A gas is in container, but container has its surrounding, and its pressure, volume, temperature of gas are not changing. Then we can say that the gas is in the system of gas is in equilibrium with its surrounding. Matter is of surrounding, not only the two bodies, two systems are said to be in thermal equilibrium if there is no change in any variable of the system. I hope you have got now it very well. And for more clarification, you can read NCERT book or any other book. Actually, I have read two books, but I found it is more clearly written in NCERT book. Actually, for learner, it is easy to say that when we place two bodies at different temperature in thermal contact, heat flows from one and temperature becomes same. So only not temperature. There are other variables in mechanics like pressure, volume, temperature. We will be dealing it now when we will come to other chapters, other topics. Now there is zeroth law of thermodynamics. The whole exercise here done by me is to explain zeroth law. Zeroth law of thermodynamics. So now you have got what is thermodynamics, the branch which deals with concept of temperature and heat and conversion of heat into other form of energy and vice versa. Suppose here two systems A and B separated from each other by insulating wall. This is the insulating wall. Means bad conductor of heat are placed in thermal contact with other system C, and it is conducting wall. Conducting wall, also called dithermic. Please note these topics, dithermic, or it is in adiabatic wall. Dear student, please work hard and try to understand. It is very interesting to know the things happening around us, and it is told by physics only. It is C here. Initially, the state of A and because A and B are not in contact with each other, so no transfer of energy means heat will take place. While if C is in not thermal equilibrium, then heat flow will take place, and very soon A and B come in thermal equilibrium C. Means the variables of C stop changing, variable of variable state of A and B do not change, then we say that A and B are in thermal equilibrium C. Now we replace this insulating wall between A and B when A and B has come in thermal equilibrium C, and we change this wall by conducting wall now. Conducting wall. And C with insulating wall. ये फिर यहाँ insulating wall. C is there. So state of A and B, state variable of A and B are now being in contact. It is not changing. Sorry, are not changing. First we place A and B together, separate by insulating wall, but they are in contact with C. So initially the state variables of A and B, like temperature, pressure, volume, may change. And A and B and the variable of C and the stop. Then we say A and B are separated with thermal equilibrium C. Now we place A and B separated by conducting wall, dithermic wall, and C insulated. Then variable state of variables of state of A and B do not change. It means A and B are also in thermal equilibrium. Actually, I am telling totally in different way. In classroom, this is not taught this way also, because teachers are in very much hurry. They don't have time. They simply want to introduce with the topic. It is your duty to read the book again and again. So what we say that A, B are in thermal with each other, and hence according to, now I say what is zeroth law. So I say here according to zeroth law of thermodynamics, if any two systems A and B, say A and B, are in thermal equilibrium with C, with a system C independently, means A and B are independent of each other, but independently. Then system A and B will also be in thermal equilibrium. A and B are also in thermal equilibrium with each other. A and B are also in thermal equilibrium with each other. And state of thermal equilibrium tells us that I told you there are different variables: pressure, volume, temperature, mass. System are in equilibrium, then temperature of two will be same, and hence if any two system are in thermal equilibrium, with each other. Then the two are at same temperature. तो दिस फर्स्ट लॉ ऑफ थर्मोडायनेमिक्स और कह लीजिए और जीरोथ लॉ ऑफ थर्मोडायनेमिक्स और थर्मल इक्विलिब्रियम. But zeroth law tells thermal equilibrium. What is the meaning of thermal equilibrium? Thermal equilibrium tells temperature. Since this law was derived by a person whose name is R.H. Fowler. R.H. Fowler. R.H. Fowler. Formulated this law after the first law of thermodynamics. So this law is called zeroth law. Fowler formulated this law very much later than first law was formulated. So it is called zeroth law due to this reason. That's all. Thank you. We will be meeting in next video with more information, that is heat and work, conversion of heat and work done by thermal system, etc.